Thanks, Susan. And whoops, is this working? Is this one working? Yes, good. I wasn't speaking into it. And you're okay here and up the back? Yes, good. Welcome back, people. And it's been a long time since I last saw you, and before Christmas sometime. And you'll notice there's a change in my title because I have retired. Yay! But I'm still connected to the university as an emeritus professor, so I can do this sort of work and work with my PhD students and help with ongoing research, which is really exciting. Very pleased to be here. Tonight's session is about the really big idea. All the others to some extent fell into place when we identified this as the idea responsible for the 7-year range in ability and in terms of performance in mathematics in years 4 through to 9. We looked at trusting the count, we've looked at place value, and what I wanted to do now is to start this session, before we get right into it, I'm just going to do a bit of a review of the big ideas in number. And then I'm going to have a pretty quick snapshotty sort of look at additive thinking, because although it's not a big idea, it is an absolute consequence of trusting the count and place value. And I didn't want to, because it's also critical in terms of leading into number fact knowledge, I didn't want to leave that out. So then we'll have a look at what's meant by multiplicative thinking, and we'll look at the key ideas in multiplication, division and so on. And then I think something that's close to everyone's heart is developing the multiplication facts, the strategies for developing those facts. At the moment, we're not doing a particularly good job of that. About 30 to 40% of students going to secondary school, if you ask them what they would most like to be able to do in maths, a very large percentage of them say, I would like to know my number facts. Now, we have spent an awful lot of time in primary school trying to get them to know their number facts, and clearly all that effort's not necessarily very successful. And in many cases, and in fact I believe a survey in this very state of, I think it might have been a wellbeing survey some years back, identified that about year 3 those wellbeing attitudes started to take a nosedive. And I would like to think that it was because we started doing, insisting on memorisation and rote learning and putting the pressure on kids to perform before they were ready. So I'm going to say something here and we'll develop it later on. There is no excuse for students in primary school leaving primary school without access to strategies for all of the multiplication facts. No one who is educable should go to a secondary school not confident that they can't work out quickly and efficiently, if they don't know it automatically, their multiplication fact, and beyond that too, way beyond that. So 23 nines. I expect them to be able to do 9 23s in their heads. We're not achieving that at the moment, and it's because of the way we're teaching it. And I'm going to give you an argument tonight that yes, we need to do this, but we need to do it in a totally different way. So those of you that have started the year teaching times table in their traditional form, I'm sort of going to disrupt the thinking a little bit, and I'll keep that in abeyance for later, so you'll have to hang around. Okay, so we're going to look first of all, as I said, I did last time, just review some of the slides we had in that introductory session about making a difference in formative assessment. So we know from some pretty big names in education, excellence in teaching is the single most powerful influence on student achievement, and we've just heard that very eloquently from Susan. Well-grounded evidence of pupils' progress or progressions in learning are crucial to the work of teachers. An assessment for learning is one of the most powerful ways of improving student achievement. Some would say it is the most powerful way of ensuring student improvement. So formative assessment, in their review back in 1998, Black and William concluded that the use of assessment to inform instruction, particularly at the classroom level, in many cases effectively doubled the speed of student learning. We can't ignore this. What is fundamental to the big ideas is about identifying where students are and providing advice about where learners need to go to next, and providing advice equally about how you might get there. So essentially formative assessment. Dylan William talks about those three things quite specifically as key processes in learning. So knowing where the learner is right now, knowing where the learner needs to be, and that's not necessarily in terms of the curriculum. Because if you tried to identify where every learner was in terms of the curriculum, you'd quite frankly go batty. Okay, that's not what's important. The curriculum is important, but in terms of progression along and understanding of the curriculum, it's about knowing where they are, in my view, in terms of the big ideas, because it's that makes a difference to how students engage with the curriculum. Secondly, we need to know where the learner needs to be, and that's, as I said, not necessarily the curriculum, it's about these key ideas that underpin the curriculum. And of course, we need some strategic advice on how to get there. Dylan William unpacks his formative assessment strategies in terms of 5 strategies. Clarifying, sharing and understanding learning intention, so that deals with point 1 up there. Where the learner is right now, engineering effective discussions, activities and tasks that elicit evidence of learning. Feedback that moves learning forward. Activating students as learning resources for one another. And activating students as owners of their own learning. One of the things that I'm finding, I'm saying a lot at this time of the year, I've been doing a lot of work in schools and with systems as the school year starts, I might just share with you, and that is, we're doing too much work. You're working too hard. You know that anyway. We're, in trying to differentiate everything, we are creating a huge rod for our backs. You do not need to differentiate everything. You just need to differentiate those things that we know make a difference. That is, where kids are in relation to the big ideas. So I'm making 2 qualifications on Dylan Williams' framework. It's, you know, where is the learner should be in relation to big ideas. Where the learner needs to go should be in relation to the big ideas. And how to get there should be quite focused on tracking them through those big ideas. So yes, of course there's difference. Of course there's difference, and yes, we need to deal with it. But differentiating everything is not the answer, okay? We now know, lots of research on streaming knows that putting kids into ability groups does not work. And I'm now very critical of ability grouping in maths. There is no such thing in my view as low, middle and upper. My first question back to teachers is, what are you basing it on? And if it's based on PAT-M or NAPLAN, that's not good enough. Because kids can be at the same band in a NAPLAN or PAT-M test for completely different reasons. And the example I use is perhaps a little boy who may not be very strong on his processes and his number fact knowledge, but may in fact be really gung-ho on measurement because he spends every weekend in the garage with Dad. By locking him away in a low ability group, he's not getting a chance to share his knowledge and to shine. And that is what oh gosh. I don't think my pointer works on this. Yes, it does. So activating students as learning resources for one another. I just wanted to take the point to talk about this at the beginning of the year. You know, as we think about our group structures and our lesson formats and things, we need to really take that on board seriously. And to my way of thinking, that means students need to be exposed to their peers, all of their peers. Not in their supposed little groups, but all of them. And that requires quite challenging or mixed tasks. I talk about them as horizon problems, and I'll share a couple of those with you today. So just placing things in front of kids, they're not huge investigations or projects, they're straightforward sort of problems, but they're at the horizon. And by placing them at the horizon and seeing kids grapple with them in a mixed ability settings provides not only teaching opportunities for you, it provides opportunities, very powerful opportunities, for students to learn from each other. You are not the only resource in that classroom. All those students there are resources to each other, and locking them away into so-called ability groups isn't doing anyone a favour. So I just wanted to really make the point there about that often it's not emphasised enough, this particular strategy. And then activating students as owners of their own learning. If everyone is in a say let's have a 3-part lesson. Yes, we know warm-ups work. Regular things, no sabotaging, little quizzes, done every day, 5 to 10 minutes. We know that works. Something on place value, something little, whatever. Followed by some of these horizon problems or mixed ability type activities. You then work in a focus group, 1 or 2 focus groups, 10 or 15, 20 minutes, depending. But that focus group is totally determined by very, very specific evidence in relation to big ideas. It's not determined by NAPLAN or PADM. It's determined by, and I'm hoping people have had a bit of a chance to have a look at some of the trusting the count and place value tools. It's determined by this group of children performed in exactly the same way on tool 2.1, place value, making and naming. Okay, so I'm going to take them as a little focus group and I'm going to look at the teaching advice, and there are 3 dot points there. I'm going to choose one of them, and in my focus group for 10, 15, 20 minutes, I'm really going to, focus in on that. So that's what I call targeted teaching, and that's why I'm using a term that's not, it is a form of differentiation, but I want to distinguish it from differentiation because it's not just differentiating everything. That's really, quite frankly, impossible. It's about really focusing in on the things that make a difference, and that is the very specific aspect of a very big idea. And so, as I said, we are all on about formative assessment, we are all on about students learning, but I wanted us to take seriously that advice of Dylan William about those last 2 strategies. We tend to get them, they tend to get a bit lost. Okay, so here are the big ideas that we've talked to today. Now I've actually added something else to this slide than was in the previous slide because I want to make a point very strongly about the role of sharing. Sharing is a key aspect that's in foundation. It's what students come to school with, and it is now recognised as a very, very powerful way into multiplicative thinking. So yes, counting in equal groups is one way, but a very powerful and parallel way is now being recognised. Extensive research in the United States, our own research, has shown that very young children can approach multiplicative thinking from an early years. And as in all these big ideas, they all have their groundings in those first years of schooling. There are responsibilities for every big idea at every level of schooling. So if you're teaching 5-year-olds right now, you have a responsibility to establish not only trusting the count, but a really fundamental premise for multiplicative thinking, which is sharing. So providing lots of activities and experiences of sharing, talking about equal groups, talking about fair shares, talking about, I've got 3 groups of 5, 3 5s. Okay, so introducing the language, pointing to what's there. You also have a huge responsibility, not teaching multiplication, you're providing experiences. Remember, those of you here that day 1, I talked about yellow. Teacher's role is to provide experiences because you can't teach a concept. We all learned yellow by having many, many experiences of yellowness, and we constructed a concept of yellow. And that's our role as teachers. For concepts our job is to provide multiple experiences, and sharing is an incredibly powerful one for multiplicative thinking. So if you're in that first year of schooling, reception, transition here? Reception. I'm sorry, I've been in so many states, I keep forgetting which is which. I don't like foundation, but anyway, I should say foundation. Foundation year 1, really important to do sharing, and don't just do it once. It's something that you do all the time. Do it routinely, sharing out pencils, sharing out sports equipment, talking about sharing out, Smarties or fruit or whatever into fair shares. So don't just do it once or twice because it's mentioned in the curriculum. It's a key idea. Make sure you do it every 2 to 3 weeks. Have some activity, some experience that focuses attention on sharing. The other big role for multiplicative thinking, of course, is the notion as a composite unit, and I'll come to that a bit later. The idea that I can count collections by 2s or by 5s. We talked about chicken scramble previously. That is also leading into counting larger collections more efficiently is a fundamental plank, and you can see how that relates to repeated addition aspect. So every teacher at every level has responsibilities for developing aspects of these big ideas. And for instance, sharing also relates to the next big idea, which we'll deal with next month, which is partitioning. Now, it's non-negotiable by the end of primary school. It has its beginnings, its foundations, literally in foundations, in reception. So I've just added this one here because I want to make a point about the link between sharing, which is very early on in the school curriculum, to multiplicative thinking. And I want to digress, as I said I would, to have a little consideration of additive thinking. It's not a big idea. Very important, but it's not a big idea. It is dependent on two big ideas and an understanding of equivalence. Now, there's a very good reason why there's no recording in the first year of schooling. The use of the equal sign has been incredibly badly misused and mistreated and is well known to be associated with known difficulties in algebra. It's one of the major difficulties kids have with algebra is misunderstandings about the equal sign. They think it means makes or the answer comes next. Now, I can understand when we're modelling addition, which we do need to do in those first year of school. Kids know all about addition. They've had lots and lots of experiences of getting more, wanting more, having more. But yes, in school we still need to model the idea of combining, joining, and we still need to do that. But we need to then, if we know that the kids know 2, for 2 and 3, we're going to cover 2. And if we know that they know 3, we're going to cover 3, 4, 5. And if we know they know 5 from sabotaging, we're going to cover both of them. And we're going to get, close your eyes, imagine it on a 10 frame. We need to scaffold these strategies from day one and start setting expectations about what's required. So, additive thinking, again, we need to model it. We do not need to record it. You're providing experiences around a concept. And so we need to delay the use of equations, the use of the equal sign. As I said, I understand why 3 birds and 2 birds, we put them together, it makes 5 birds. I can understand why we use that language, but it's really unhelpful. Much better to say 3 and 2 is 5. 5 is 3 and 2, is the same as. So if you can note that down as a language little jotter, it's quite important to do that. Okay, so let's take a little sideways trip into additive thinking. So, additive thinking is a consequence of trusting the count and place value, and I'll just give you some examples of that. So, when we develop additive thinking, we've got concepts such as join, like with like, combine is things like I've got oranges and apples and I've got to combine them to think about fruit. Obviously, take away, kids having things taken away from them, they've got lots of experience with that. Missing add end, I've got so many Pokemon cards, I've got 8, I want 10 or I want 12. They understand that notion of wanting more. And of course, the difference idea, Jeremy's got this many and Mary's got that many, how many more does Jeremy have than Mary? That is actually quite a difficult concept. So all the others can be done first year of school in reception. But the difference idea I strongly recommend is left to year 1, okay, because it is sometimes called the comparison idea. The language and the semantic structure is actually known to be quite difficult for young children. One of the ways, there's been a lot of research on additive thinking, and a lot of it's got down to the structure of the word problems and whether change is involved, and it's quite a lot of technical language around this. Fundamentally though, it's about part whole, and that's where this link and this connection between sabotaging, so when we're sabotaging we're learning about the numbers in terms of their parts, but clearly that has a link or a connection to additive thinking. So one way to characterise addition and subtraction, and quite young children understand this, and it's actually a useful strategy for helping kids work out from a complex word problem, what do I know? Do I know the whole, or do I just know the parts? Do I know the whole and one of the parts? And so it's a way of helping to work out what the structure of the situation. And young children can generalise. They can work with these sort of, if you like, templates and think about, is it this or is it that? How do I know it's a part? How do I know it's the whole? And this can be quite a powerful lever for getting kids to think more in a metacognitive way about the problem situation, not just rush in and do things with the numbers. So for addition, we know the two parts and our object is to find the whole, and there might of course be more than two parts. For subtraction, our object is we know one of the parts and we know the whole, and their object is to find the missing part. So in prep, all my little pictures haven't come across. I wonder why. Perhaps that's a censorship thing. It took me forever to find them too. I had little pictures of cats and birds and fish and what have you there, as you might in a classroom at this level. Explore what it means to think additively. Pose questions that require children to distinguish between part and whole and recognise when order matters. So for instance, if I asked how many four-legged animals, okay, how many? This is encouraging students to recognise that there are more than two add-ins there. I've got cats and I've got dogs and I've got guinea pigs, and I need to work out how many in each and add them all up. And in this case, I need to recognise that the order in which I do that doesn't matter. You know, I can start anywhere and add those numbers, I'm going to get the same total. You need to explore things like this and get the kids to frame generalisations and record them in their words and put them up on the board with some examples. How many more birds than guinea pigs? How many more birds than guinea pigs? Now that's quite a complex question. It's actually a difference idea. And again, I need to recognise here that order does matter. Although the structure of the sentence sort of implies that, how many more of this than that? And you can see that that also relates to things like length and measurement, you know, the language of more and less, and of course it also relates to our subitizing text, you know, 8 is 5 and 3 more, you know, 8 is 2 less than 10. So there's a lot of this stuff that sort of, we can be working across curriculum strands to the same end. So we might be working with, you know, simple statistical, you know, representations, data representations, but using them to help students structure their ways of thinking about addition and subtraction. So we've tended to jump too much into written recording too early and get the materials out and count and record. We actually need to take a little step back and provide experiences with word problems and act it out and with situations to understand the nature of addition, the concept of addition and subtraction. So the counting strategies I've already mentioned in passing, we need to actually scaffold children from making and counting all to counting on from covered, counting on from larger. And eventually we want to proceed to a situation where they trust the count and they're capable of working with mental strategies. I'm sorry my pictures hadn't came up. I can't tell you how many hours I spent finding them because I had to find free ones, so I'm a bit surprised they didn't come up. Okay, so well, that's meant to be a teacher's head. I'm not quite sure why they're not coming through. So the teacher's asking 2 and 8, and notice how it's oral. 2 and 8. You know, what do you want to think? We need to structure children's thinking. I'll put these all in, I don't know why they're coming up separately. Count on from any given combination, you know, the strategy of 1, 2 or 3. It should be no more than 1, 2 or 3. So any combination involving 1, 2 and 3, we grab the larger one and count on. A nice strategy is 2 and 8, grab the largest number. 8, 9, 10. Okay, 2 and 41, grab the larger number. 41, 42, 43. Now, quite a lot of kids early on don't need practice at doing that. They want to go back and start from 1 to get to 41. That's telling you they don't trust the count, by the way. So they need more activities with counting so that they're more confident that a collection of 41 is 41 and I can just say 41. But using those physical activities to identify the larger number and then count on is a way that you can practice that. And then this can become quite a regular warm-up activity. Remember, we're doing the 1, 2, 3 count-ons, you know, even indicate it by hand signal, and we'll practice some of those, but use any sorts of numbers. Doubles and near doubles, counting on, by the way, we should be able to get to, by the end of reception, certainly into beginning of grade 1. Doubles and near doubles we should be able to get to by the middle of grade 1, end of grade 1, particularly if they had lots of subitizing and analysing numbers in terms of their parts. Last time when I talked about trusting the count, I mentioned that really critical aspect of, you know, the doubles to 20, and we had an arithmetic rack with 2 different colours, you know, red and blue, and you could see that an 8 was a 10 and a 6 more. Double 8 was a 10 and a 6 more. So doubling is really, really crucial. And if we can get parents helping with part, whole and doubling, a lot of these additive strategies will come along for the ride. So the first 2, we can accomplish pretty early on. The strategy that's by far the hardest is the make to 10, and this is the best indication of trusting the count, because you need to simultaneously know that 8 is a 2 less than 10 and 6 is a 2 and a 4. And you're not doing, I'm taking 2 off the 6 and like adding it to the 10 and that the 8, and that gives me 10, but because I took 2 off the 6, that's 4, and now I've got to add the 4. No, verbal linear sequential rubbish. Kids have got to be able to do this simultaneously from multiple experiences of working with visual representations. For instance, they want to see that, you know, imagine a 10 frame. Imagine an 8 and a 6. What would it look like? Your mind's eye wants to drag those 2 there I'm seeing a whole 10 and a 6 more. So it's that using that visual activity, and we need to scaffold that as well to demonstrate that and introduce the idea of open number lines. So just to extend that a little bit more, my goodness me, all my pictures have gone after all that effort. Okay. Why is that not? They're all coming up in funny ways. It's interesting. I might fix this up and send it to you again. Sorry, I'm not quite sure why that's happening. We need to extend the strategies, and we need to take particular care about introducing the equal sign. This is difficult for children. This is one of the areas where Piaget's work is incontestable. He discovered way back that it's only about years 7 and 8 that children really are in a position to understand the equal sign, and that's still the case today. It's a logico-mathematical connector. It's quite an abstract idea. It's actually more related to algebra and in a beam balance sense. In fact, a very good way to introduce the equal sign is with a beam balance. So, but you'll notice there that I've got 2 sets of numbers. 5 and 4 is equal to 6 and 3. Very important to not have, the answer is next. It's about equivalence. So if I already really know 9, I know all my part wholes, I can start writing down what that means in equations. 9 is a 5 and a 4, a 6 and a 3, a 7 and a 2, a 10 take away 1, and so on. So we need to capture what is known in this way, but what is really important is that notion of equivalence and the fact that there are 2 numbers on the right-hand side and that there are multiple ways to write this. I could write 9 is equal to 5 and 4 is equal to 6 and 3 is equal to 10 take away 1 and so on. It's about equivalence. This requires a confident part whole understanding for each of the numbers to 10, so critically the trusting the count, and I need to then extend this beyond single digits, so 26 and 9. Hopefully we've got students thinking, well, if I add 10, that's 36, I've got to take 1 away. But they could also think, well, 26 and 9, 4 is up to 30, and 5 more, 35. So we want them to be working confidently with known parts, numbers in terms of their parts. We need to encourage students to represent and record this in multiple ways. And so we do want to introduce, 37 and 56. What do kids do? Well, often what they'll do is they'll add the 10s, 8 10s and 13 1s, 93, left to their own devices. And what you're looking for here is that separate count of 10s and 1s. So rather than 30 and 50, 3 of those things and 5 of those things is 8 of them. Okay? And then I've got 13 more, it's 80, 13 more is 93. We want to introduce students to number lines. Now, there are lots of ways we can explore with open number lines, but again, for assessment purposes, if in this case, someone writes a number line, goes 56 to 60, and then goes 70, 80, that's telling me something quite powerful. Yes, it's a way of doing it, but what it's telling me is I'm actually not confident about 10 as 110. I'm not really confident about place value. Because if I can only manage the count of 10s in the multiple of 10 naming sequence, that's really the count of 1s by 10. It's not place value. What I'm looking for here is this. I ignore what's in the 1s. It doesn't matter what's in the 1s because I'm counting 10s. The 1s come along for the ride, whatever they are. So 5 10s, 6 10s, 7 10s, 8 10s, then I deal with the 1s. Okay, so be on the lookout for students relying on a count of 10s being in terms of the multiple of 10 language, because that's suggesting that they're not really confident about place value. They're not seeing that the numbers in the 10s place as a count of 10s. They're still seeing them as 30, 50, 80, whatever, and then they're locked into that number naming sequence. So that's a nice little bit of, again, informal assessment that you can do, a diagnostic or formative assessment, that you can give immediate feedback. You know, you can be wandering around the classroom thinking, I've noticed a few people are doing this. Why do we think, doing the ones in the countings by, 60, 70, 80. Why do you think some people might be doing that? Without naming names, just actually unpack it and draw to attention that might mean that they're not really comfortable about the count of 10. So use these from the student work, from your notices of student work, or you might see that and really, at the end of a lesson, a reflection, I really noticed a couple of kids did this is really great. Because what this is suggesting is you're not caring about the ones, you're really just focusing on the count of 10s. That's terrific. And so you are valuing and pointing to and noticing the key idea here, which is that the count of 10s is separate from the count of 1s, and it might be called 30 or 40 or 50, but that's 1s. We don't want to use that language. We want to use 3 of them, 4 of them, 5 of them, and that's the point we made last time. Now, the other thing I want to point out here is that there's a few more things that may or may not be aware of, because of course all the curriculum talks about is adding and subtracting. It doesn't talk about how. It just says mental, written and digital forms. Notice mental is first. That's quite deliberate. This is an example of relational thinking, and it's now being recognised as one of those 21st century schools, and a lot of people are talking about and it's a sort of pre-algebraic skill. It's really important we give opportunities, and that little unknown box could be anywhere. What we want students to do with this is, without calculating, work out what goes in the box. And so what they've got to recognise there is that if 48 has been increased, what I'm subtracting has been increased by 2, what's got to happen to that box? Can you see how this is getting at the essence of a concept or an idea? I've got to preserve the difference for that to be equivalent. So what goes in the box, of course, is 85. Agreed? I've got to, if I'm increasing what I'm taking away, I have to increase the amount I'm taking it from, if that makes sense. But this is fundamental. It's sort of like pre-algebraic thinking, it's relational thinking. It's actually sort of indirectly in the curriculum at about grade 3, 4. It's a bit hard to really tease it out, but I found a statement in the algebra part of year 3 that suggests that this is the sort of thing that needs to be done. But it just says use equivalent number sentences or relationships and so on. Now, this form of recording, okay, which children can generate themselves, and I'm not so worried about the 5-0 here. What is far more important here is this vertical record, this sort of systematic use of equivalent number sentences. Now, probably none of you have seen that before. It's now recognised as it's called computational or algorithmic thinking. It's very much related to coding. You know, we all get jumped on the bandwagon of coding, but a much more general principle behind coding is we do this and then we do that and then we do the other thing. You know, that's the general principle. And this is the sort of recording that you need to mount an argument, to show your reasoning, certainly later on to convince someone of, you know, an algebraic equation, you know, rewriting and renaming. We need to teach kids how to do this recording. It's not just about getting answers. If you like, that's a genre. It's a very important mathematical genre, and I know we can get the answer more quickly. I'm not interested in that. I'm interested in the text. I'm interested in the writing. We need to teach kids how to read and write mathematically, but powerfully, we need to teach them how to show their working. One of the big problems, we now have to work with the proficiencies of reasoning. That's reasoning. I can see someone's reasoning when I see that. If they just do a column thing, put down this and carry that and write that there, have they done it by rote, just churning out facts? You know, what do they really understand when they show you that sort of an algorithm? You don't know whether they've arrived at the answer for the right reasons or they could have copied for all you know. But if they've got to generate that text, there's no dispute. Okay, they've had to construct it, and there are multiple ways to do it, and you would encourage kids to do it in multiple ways. So what we're really valuing here is this form of recording. It's called algorithmic or computational thinking, and certainly in any further reviews of the curriculum, this is going to it'll be much more amplified as being a requirement in the curriculum. But I want to just bring it up as this is about teaching kids to write mathematically. And in primary school, we have a huge responsibility about that. This is also about equivalence, and it's just really demonstrating how critical this notion is. And I'm taking way too long to do this, but anyway. This, I thought I'd just leave, we'll finish this as the last one. I thought I'd just leave this with you. This set of, there's something very similar to that, those little boxes at the top, as the 3.2 additive strategies tool for multiplicative thinking. So you've all got your folders, you may or may not have them with you, but if you look at the additive strategies tool, 3.2, then it's not the same numbers as this, but it's the same structure. Actually, I think the first one is, no, it's not. The idea is that you introduce this little 2x2 grid with some very simple numbers, 3, 2 and 4. Whichever way I add them in whatever order, do you agree I end up with a total? Yes, I agree. Okay, let's have a go at this one. What you're looking for here in that first one is the sort of strategies they're using. Actually, I think it might be this. I think I've got 8. I think it's 8 in the actual tool. Anyway, what you're looking for here is, are they able to go to perhaps use a near double here to say that that's equivalent to double 8, 16, and 6 more, 22? Or do they go 9, 10, 15, 5 more 20, and 2 more 22? So we're looking, or do we use a double, 6 and 6 is 12 and 1 more is 13. Adding 10 would be 24, but I've got to take 1 off, 23. So multiple ways of doing it. What I'm looking for are efficient strategies that teach the numbers as composite units and in terms of their parts. I'm not counting by ones. So if you see kids counting by ones, but they're not ready for to do much more further work. You need to target, trusting the count and place value, because it's not additive strategies that are problematic. They don't trust the count, or they don't know place value. That's the issue. Now, this bottom one is a really nice assessment task. And this uses what I call a thinking string, okay, a thinking string. And you write down the numbers, and it represents a thinking. I went from 78 to 68 to 58 and so on. And then the students have to describe in words what you did using, well, you started at 78, you took away 1, 2, 3 tens, not 30, 3 tens. And then you, 48? Well, what have I done here? 48. 48, but I've gone to 50. I've added 2 back. Oh, I've done something stupid there. I'll have to look at it. 78, 78. Anyway, you then, 3 10s. I've added 2, taken away 3. So I've taken away 1. Okay, that's a bit confusing. I've done something wrong. It doesn't matter, I mean, anything there is legit. The thing is, students have to describe what the strategy is, and in words, and then they have to write an equation. Okay, 78 take away 31. 78 take away 31 equals 47, and they might write that in at least 2 ways. Then they have to draw an open number line to represent the strategy on the, actually I think that's why I did it. You know, going backward, like so you're going backwards, 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 and then you go forwards and then backwards. Write a word problem to match the subtraction, and so on. So obviously start with a simpler one, but it's just a way of assessing our students thinking mentally around these strategies. Are they able to represent them in multiple ways and so on? So I'll just leave that with you and we'll move on. I've already taken quite a lot of time to do that. Okay, so by the end of year 2, these aren't all the curriculum descriptors, but the key ones. Group, partition and rearrange collections of up to thousands in hundreds, tens, ones and so on to explore the connection between addition and subtraction, and I've tried to demonstrate that. Solve simple addition using a range of efficient mental and written strategies, and I've tried to show we need to do much more than just work with icy pole sticks and vertical recording. Recognise and represent multiplication as repeated addition, groups and arrays, this is year 2. Recognise and represent division as grouping into equal sets and solve simple problems, so that is building on those sharing experiences from day 1. And recognise and interpret common uses of halves, quarters, eighths of shapes and collections. So we're well down into it. And of course partitioning is another form of multiplicative thinking. There's the tool there. There's the actual additive strategies tool that's in your handouts, your folders. So that little framework is used to establish that it's okay to start anywhere. And we work through these, and I've already talked about that one or something similar. This one, we're looking for a missing addend, and here 7 and 5 is 12. We're looking, do they recognise that that's half of, without doing any form of counting? But this is what I want to point to in this tool. This is the key. Do they, and I mentioned this just before, but are those numbers like 3 10s and 7 10s is 10 10s, and 5 more 10s is 15 10s, and then that 8 and 2 is another 10, so 16 10s, and 4 1s, 164. Now what I'm looking for there is that distinct, that count of 10s using single digit names separate from the count of 1s. Does that make sense? And so that's, if we've been focusing on 30s, 40s, 50s, it's not helping place value, but equally it's too much of kids are then thinking in terms of those quantities, and it's too much to keep in their heads. So that's really just testing, if you like, that trusting the count and place value. So here are some responses to that. So this is in the multiplicative sets of tools. So some of these students you've met before when we've had some of their early. Ben, who's in year 10, said 68. There's a 6 and an 8, so it must be 68. Now he's already agreed that the little earlier example, they're adding the 3 numbers to get whatever, is okay. Amy in year 3, 23. I started with the biggest number, then I added the smallest number and then the smallest, but she counted by 1s. And you do need to be aware of and watch how kids are doing this. Leah in year 3, 14, 23, I just added. Okay, now, so considerable difference here. What's happening here? There's numbers, should be numbers there. Okay. Yeah. Yes, I'm sorry. It's anyway. This is the 7. Sorry, this is the 7 and 5 is 12. And this is the missing add-end one. I'm not quite sure why it's not there. So 7 and 5 is here and 24 is there, and they have to recognise that the missing number is 12. So Ben didn't attempt it, but Amy in year 3, to make 24 I add 7 and 5 by counting on 12, recognised 12 more was needed. Leah, 12, because 7 and 5 is 12 and that's half. So it's just looking at the extent to which students notice these relationships between numbers. So quite an interesting tool to use as a bit of a precursor, particularly grade 2, grade 3, grade 4. So this is the extension of that tool. So we've seen, Amy year 3, 16. I had to add on. I added those numbers 3, 7 and 5, and then I add these numbers 4, 2 and 8. She's just treating them as single digits and just adding them up as if they're ones. Amy did not attempt. Leah, that's 100, 106 pointing to the top row, so 100, 106, 50, 56, 160, 164. Can you see she's using mates of 10? For this one, which is the extended missing add-in version, did not attempt, Amy didn't attempt, but Leah, that's 40, so 47. So again, you can see clear differences in the children's thinking within the same year level. So it's quite revealing. Now, curriculum expectation is that students by the end of year 2 will know all their additive strategies. They won't necessarily be able to do the 2-digit ones. I'm not expecting that until the end of year 4. But it's nice to know where they're at and what their thinking is. And so you can see how that, I just really want to point how critical trusting the count and place value is to working additively. Okay, so perhaps take a little moment, we won't do this for too long, take a little moment just to stop and reflect in what's your takeaway message, to just think about what will you continue to do, what in your practice has been reinforced or confirmed by what we've talked about. What are you currently doing that perhaps you could improve upon? What will you stop doing? And what do you need to start doing that you're perhaps not currently doing? So just take a few minutes to do that.